Okay, I guess it doesn't say recording has started, but hello everyone. Welcome to another Open Cluster Management Community Meetings. Today's topic is about policy template. We have Matt from the OCM Policy SIG here to present to us. So without further delay, Matt, please take it away. Thank you.
All right, thanks. I'll share screen. Okay. So before, hold on a sec.
Can anyone hear
You're
Matt?
mute. No, he's on mute.
For some reason, I wasn't able to unmute. Okay, I'll try again now. Okay, that's odd. When I share a Chrome tab, I can't unmute myself. So I'll try sharing the window instead. Okay. Can everybody see the screen all right?
Yep, and we can hear you. Thank you.
Okay, yeah, sorry about that. Okay, so I'll just go over a little bit of the policy API concepts to make sure we're all on the same page. If you're new to policies, we have more details on this in the Open Cluster Management IO website. So if you're new to policies, I suggest taking a look there. And once the KubeCon EU presentation that I did a couple of weeks ago is up online, you can watch that recording as well for more context. But real quick, the main concepts for the policy API are policy templates, which are the policies that actually perform desired checker action. So in this case, in the demo, I'll be showing you configuration policy. And then a policy is a grouping mechanism for those policy templates. So the policy templates are actually embedded in the policy itself. And the policy templates are embedded in the policy itself, and then the policy is actually what gets distributed to the managed clusters. Status about whether a policy is compliant or not gets aggregated on the hub cluster on the policy object itself. And then lastly, I'll mention that a placement binding is what binds a placement to a policy. And if you're not familiar with placement, it allows you to select which clusters that you want something distributed to. In this case, we're talking about a policy. So diving into the actual main purpose of this presentation is policy templating. And so it allows you to dynamically configure the configuration policy definitions. So it does this by using Go text template syntax. So it's similar to Helm if you've used Helm before. There are two main types of template functions. There are the hub template functions, which I'll show in the demo, which are denoted by using the double curly brace and hub afterwards. And so anything within these double curly braces and hub will be executed on the hub, on the policy, on the hub before it gets distributed to the managed cluster. And the main benefit of hub templates is it allows you to have one policy, but have dynamic content, say, for each individual managed cluster. So you can have that policy be specialized to each managed cluster or a subset of managed clusters without duplicating that policy for every single managed cluster. And this will be clear in the demo coming up. And then if you want a template function executed on the managed cluster itself, it's just the double curly brace, meaning if you're going to be performing an action and you want to take place after the policy has been distributed to the managed cluster and the policy is being evaluated on the managed cluster, you would use those double curly braces like that. And so here are some examples here where I'm saying I want to grab the field from a config map on the managed cluster by this name and in this namespace. And similarly, I can do this from the hub point of view. I can do like from secret. And And then on the hub, I forgot to mention, there is a restriction where you can only access objects that are in the same namespace as the policy that you defined on the hub. There isn't a restriction for the managed cluster templates. So in this case, I just leave the namespace empty because it'll just default to whatever the namespace the policy is in, the name of the secret, and then the field within that secret. And I'll show this specifically in the demo. And then if you want to just do something generic, for instance, say you want to grab a field from a service, you can use the generic lookup function here, where you're just specifying the API version, the kind of the object that you're trying to access, the namespace, and the name of the object, and then you can then get the field that you're interested in. In this case, it's under the spec object of cluster IP. So I'll move on to the demo by switching my screen share. Okay, so to first get started, I'm going to be demonstrating the managed cluster side template functions. And I'll just create this config map that you see here. I'll make it a little bigger, perhaps. This config map on cluster one. Actually, before diving into there, I just wanted to show the environment that I'm working in. So I have a hub that has two clusters registered, cluster one and cluster two. And then I have labels associated with each. So I have cluster one in the data center of Raleigh, and cluster two is the data center of Boston. And so on the right-hand side, you can see that I have three terminal tabs, the hub, cluster one, and cluster two. So on cluster one, I'm just going to go ahead and create this config map. And then I'm going to go ahead and apply this policy. And while we wait for that policy to apply, I'll just walk us through it. So this policy is called OCM demo. It's in the policies namespace, and it has just one configuration policy. And this is what I was talking about earlier, policy templates being the actual policies that perform an action or a check. And so I have a configuration policy. It's set to enforce that we must have a pod. And the pod is going to be in the default namespace. And here I have some template functions. So the first one is that the name of the pod is dynamic based on the config map that is present on the cluster. And so because I have the double curly brace and I don't have a double curly brace hub, this template function actually gets run when it's on the managed cluster every time the policy is evaluated. So if we go back to that config map, you can see that I have three fields. I have name, so in this case, important website, and that's what would be substituted here dynamically. And here I have a container that I'm running. It's just called web, and then the image. I'm just using a different format from config map, where I'm just using a dynamic, just a generic lookup, just to show that you could do this with any kind of object. In this case, I'm grabbing the image field from the config map, which is shown here. And then lastly, I have this other one where I'm grabbing the config map. From the config map, I'm grabbing the port field. And you can see that it's a string, but the Kubernetes API expects this to actually be an integer. So there's some helper template functions here that you can pipe to. In this case, I'm piping the value, which will be the string of 80, and then I'm converting it to an integer. There's also toBool and then a couple other helper template functions. And there are more than just like from config map available. There's like from secret. But those are all documented on the website that Mike showed at the beginning of this meeting. And so this is meant just to give you an overview. And so lastly, I have my placement, and I'm just saying I'm just applying this to my cluster that's in the Raleigh data center. In this case, it's just cluster 1, which is where I created that config map. So I can go ahead and take a look at the policies. So I can see that, let me actually narrow this down to just the policies namespace. We can see that the policy is now compliant, and I can take a look at the YAML here. Under the status, I still have, or it shows that it's compliant, and it's compliant for just cluster 1 based on the placement that I set. So now I can go ahead and on cluster 1 verify that the policy did as I expected, and I can just get the pod. And we can see the pod is running now, called important website. And again, that was dynamically derived from the config map that I created on cluster 1. And I'll just go ahead and show the YAML for that. And we can see that it's actually an integer for a container port and not a string, which is what we wanted. And the image was replaced with Nginx. So I'll go ahead and delete the existing policy that I created. And I'll show our next example. I'll go ahead and create this. Okay, so while that's being evaluated, I'll go ahead and talk you through it. So this example is going to be using the hub policy templates. And so at first on the hub, I'm creating a secret called OCM demo source secret in the policies namespace. This is important because that's where the policy that I created is going to be in. And again, that's a restriction for hub policy templates. You can't access objects outside of the same namespace as the root policy. And I have two values here in the secret. I have cluster 1 app password and then cluster 2 app password, and there are different values. And so essentially what I'm trying to do is create a secret on the managed clusters, but on cluster 1, I want this value to be in the secret, and then on cluster 2, I want this value to be the secret. And so the benefit here is that we'll have only one policy, but it's going to have different behavior on each managed cluster. So we have this policy called OCM demo secret.
Yeah, let me tell you what Ben told me. Ben said that.
Oh, Juliana, could you please? Okay, thank you. So we have one policy called OCM demo secret, and we have one configuration policy within it. Here we're saying that we are enforcing that we must have a secret called OCM demo in the default namespace. And in this case, I have a hub policy template, because you can see that it has like the double curly brace in hub. And so I'm just saying from secret in the same namespace as the policy, grab the secret called OCM demo source secret. And then the field that I want to get is actually dynamic, right? Because we see that there's cluster 1-app password and cluster 2-app password. And so the field being dynamic, we need to dynamically determine which field we want to grab. So in this case, what I can do is I can use this go text template function that is available called printf. And I'm just saying, do %s-app-password, but replace this %s with whatever the managed cluster name is. And this is a variable that is available to you called .managed cluster name. So you could use this in other places as well, but this is how I'm going to actually dynamically determine which field is used from the source secret per managed cluster. And I'm just going ahead, have a placement that just will apply to all managed clusters. And so I went ahead and created that earlier. So let's go ahead and see our policy is now compliant. And just go ahead and show that the status on the policy says that it's compliant for cluster 1 and also cluster 2. So I'll go ahead and go on cluster 1 and first check the secret that was created. We can see that, in fact, the secret was created. It's called app-password. And then this is the same base 64 as we see for cluster 1. And then similarly, if I go on cluster 2, you can see the app password set to the base 64 based on the value that was in the source secret on the hub of cluster 2-app password. And so one of the neat things about from secret on the hub policy template is that there's encryption and decryption happening transparently or under the hood. It's abstracted for you. And we can see that by taking a look at the replicated policy. So if you're not familiar, on the hub, there's always going to be a copy of the policy that you define per managed cluster that it applies to. And you can see that you can see those in the managed cluster namespace. So it's the namespace named after the managed cluster that the policy is applied to. So in this case, I'm just looking at the cluster 1 copy of it. And there's more status details here, but what I really want to show you is app password here is this OCM encrypted prefix, and then there's some base 64 of the encrypted value. If I go ahead and decrypt that, or sorry, decode that, we can see that it's just this gibberish showing that it's actually an encrypted value, and it's not just the plain text of that secret. And the benefit here is that we don't necessarily want everyone who's able to view the policy to be able to also be able to view the secret that's being copied over. Additionally, if you're using etcd encryption, only some API objects are encrypted, such as secrets and config maps, and custom resources such as a policy would not be encrypted by etcd. And so it's important to make sure that the secret value remains encrypted at rest. And also, if you're backing up your policies, this ensures that they're not stored in plain text in your backup. So that's all I wanted to show today. I'll open it up to any questions.
I think Justin has a question. Justin, you want to go ahead?
Yeah, I wanted to see if that hand thing worked. Yeah, so I have two questions. First of all, it was really cool. The special functions in templates that we have in Open Cluster Management, like from secret and from config map, are cool. Correct me if I'm wrong. You can use any function from the standard library text templates. So I think there's some like logical things in that.
That's right. Yeah, I can show a screen share for the audience to show some of that functionality. Yeah, so I'll post it in the chat, but anything that's available here you can do. So some examples, if I scroll down, you can have like if statements. You can also do loops. Then you can also, there's some, hold on, I'm trying to find some of the example functions that are available. So there's like index, slice, length, printf, the one that I used. So there's there's quite a few available for you there that and the power of the text template language from Go that you can utilize in your template functions.
Cool. I promise that wasn't a planted question. That came up this week, and I wanted to make sure I understood it right. The other thing, and this might be me for like remembering something wrong. The namespace that you put in like from secret or from config map, is there something restricting it to only the like namespace the policy was defined in, or am I making that up?
No, that's right. Yeah. So on the hub side, any template can only access objects in the same namespace as the root policy that was created, and so the policy that we created. On the managed cluster side, though, there's no restrictions, so you can access any object.
Cool. I didn't spot that in the docs immediately, but I didn't search too hard, so thank you.
Yeah, well, yeah, thanks for bringing that up. Try to make that a little clearer in the docs. Looks like there's another hand up. Chojin, could you you have a question?
Yeah, I think I'm trying to think about the relationship between the template and I think there's an enhancement proposal from the Justin about there's a core API about a policy. So is that possible that if another part, if it's another third party that create a policy, a different policy, like not a configuration policy, but another policy that using policy API to do that, will we be able to do something similar like this for them, or it will also depend on their own controllers?
Yeah, I think that's a really good idea, Chojin. The templating library is already abstracted away as a separate Go module, so I don't think it would be that difficult to add that in. But it's definitely a good point. Since it's Justin's proposal, maybe I'll give him the last word on it.
Yeah, it's a good idea. I don't think you would get it automatically. So on the managed cluster, the thing that does the templating is the configuration policy controller, if I'm not mistaken. And on the hub side, it checks that it's a configuration policy before it does any of the hub templating. So that we could possibly change if something else might want to use it, and we would enable that. But on the managed cluster, it would be down to the specific policy controller. But it's a great idea.
All right, thanks for that. Any other questions?
Can you talk a little bit about scalability? I know a company that is interested in using policy to propagate to about 400 EKS cluster. Can you just talk a little bit about the performance and scalability of the policy? Thank you.
Of policies in general, or the policy templating?
Both.
Okay. Yeah, I'll start with the policy templating. So hub policy templates are by far the more efficient approach because it gets the value once, puts it in the policy that gets synced over to the managed cluster. So you're not constantly like pinging the API server for that object that you're referencing in the template function. On the managed cluster side, though, every time the policy is evaluated on the managed cluster, any managed cluster template functions are executed every time. So if you have one configuration policy that uses 3 template functions that each, are getting a different object, that's 3 hits to the Kubernetes API server. Every time the policy is evaluated, if you have a small amount of policies, that ends up being every 10 seconds or so. If you have a lot of policies, it would be a little more spaced out. And that kind of leads me into the scalability of policies in general. So on the hub side, not really any scalability concerns that I've seen. It's since it only does work when there's certain changes that happens, whether that's you know, a policy gets applied to a new cluster that gets imported, then that would cause all policies to be reevaluated on the hub side, or sorry, that one policy would get reevaluated for every managed cluster that applies to, and not just the single managed cluster that was newly imported. So that's one concern. But you know, those events are pretty infrequent. On the managed cluster side, at the moment, there is a all the policies are processed serially, meaning that there's no concurrency or parallelism, which is good in the sense that you're always going to only have one policy being evaluated at a time, so you're not going to overwhelm the Kubernetes API server on the managed cluster. It's bad because if you have a lot of policies, it'll take a while for your policy to get reevaluated. One thing that you can do is there is a configuration option that's documented on the community website called evaluation interval. An evaluation interval allows you to set on each configuration policy how often the policy should get evaluated. So if it's a policy that's not really critical, you might be okay with just having it checked every hour. You can do that. So I would check out the evaluation interval and think about those as you write the policies from the start, and that'll help with your scalability concerns. Does that answer your question, Mike?
Yep, thank you very much. It's mostly for the recording.
Sure. Any other questions? All right, well, thank you. I'll pass it back to Mike to close us out.
Thank you, Matt. That was a great presentation. Are there any other topics that anyone want to bring up? Qiuzheng, Juliana, anything? If not, thank you everyone for attending this week's meeting. Take care. Bye.
Thank you.